We have a pattern that's made of squares, and the little lines are the matchsticks that are forming the squares. The first figure has 5 squares, the second figure has 11 squares, and the third figure has 17 squares. The 5 square figure became the 11 square figure, which in turn became the 17 square figure. So this figure is evolving. We're adding more squares to it, if you notice. A, how many matchstick squares will it take to build the 10th figure? So you don't have to draw anything, just draw a list that has the number of squares as the figure evolves. The first figure had 5 squares, the second 11 squares, the third 17 squares. Notice that to get from 5 to 11, you would have to add 6. To get from 11 to 17, you would have to add 6. Or you could say 11 minus 5 is 6, 17 minus 11 is 6. The main point is that you're adding the same amount to get from one term to the other. If that's the case, if you're adding the same amount to get from one term to the other, you're working with an arithmetic sequence. This is an arithmetic sequence, and it has its formula. Its formula looks like this. A sub 1 would be 5, the first term. D would be the difference, or the amount that you're adding to get from one term to the other, the amount that's not changing. So 6 would be the D. So how many squares does the 10th figure have? Okay, you plug in what you know. Term number 1 goes here. The arithmetic difference goes here, right here. Term number 1, arithmetic difference. Distribute, simplify. Now you have a formula. So this arithmetic sequence formula works for this problem. If you tell it in, the term number or the figure number will tell you how many squares that figure has. So we want the 10th figure. So you plug it in where there's an n. Notice the n is in 2 places, so you plug it in here and here. Simplify, and this tells us that term number 10 or figure number 10 has 59 squares. B, how many matchstick squares will it take to build the nth figure? So working with the same 3 figures that are evolving, it's arithmetic, so you write your arithmetic sequence formula. Here it is. Plug in a sub 1, which is 5, we said before, and the arithmetic difference is 6. Plug it in. Simplify, and stop right here where the n is. Now this one is waiting for you to tell it which figure. But right here, they just want the nth figure, so you just leave the formula alone. You don't replace the n with anything. In C, they're asking for how many matchsticks will it take to build the nth figure. So now they're talking about matchsticks. They're not talking about squares. So we have to go back to those 3 figures, and instead of counting the squares, count the number of matchsticks. And if you count them, you'll see that the first one had 16 matchsticks, the second figure 34, and the third 52 matchsticks. Notice this also forms an arithmetic sequence since you're adding the same amount to get from one term to the other. So now we know that 16 is a sub 1 and 18 is the D. You write your formula down, replace a sub 1 with 16 and replace the D with an 18, simplify, and this represents the nth figure. In other words, this formula, if you were to tell it what figure, figure number 11, 20, it doesn't matter, and you plug in that number there, it would tell you how many matchsticks that figure had. But since they were asking for the nth figure, we leave the n alone. We don't replace it with anything. This is the nth term.